Hello and welcome. Are you somebody looking to achieve one of the highest grades possible in GCSE Maths? Well, if you are, then please continue watching this video as we aim to tackle the topic of quadratic equations, but more precisely, choosing the correct method so that you work most efficiently in an exam situation. As always, we will be calling upon your prior knowledge and previous understanding. It probably goes without saying that in this video, your ability to use the quadratic formula, or indeed factorise, or completing the square. But like I say, if you're looking to achieve one of the highest grades possible in GCSE Maths, please continue watching this video. So, without further ado, if I just scroll my screen down slightly, question 1. Solve x squared minus 7x plus 12 equals 0. Now, my preferred method to solve a quadratic is that of factorisation, simply because I think it's the quickest, most efficient method. And when you're in an exam situation, working efficiently is crucial. So in other words, are there two numbers that add together that have a sum, I suppose, of -7, but a product, in other words, multiplied together, to give positive 12? Well, there are. We have -4 and -3. Remembering, of course, when we factorise, we do write in brackets with our variable of x in this instance. However, factorising itself is not answering the question. We now need to solve. Now, some people simply work like robots. Once they've factorised, they flip the symbols. In other words, x1 equals 4, x2 equals 3. Now that is correct, but let me quickly explain why. What is the only number in the world that you can multiply by to get 0? Well, 0. So if we can make this first bracket 0, the second bracket becomes irrelevant. 0 times anything is 0. So ask yourself, x take away 4. In other words, something subtract 4 is 0. And that's why we flip the symbol, 4. Or we could make the second bracket 0. Something subtract 3 is 0. Hence, x2 is 3. That's the reason why. But like I say, a lot of people, most people do just flip the symbols once, of course, they've factorised. Let's move on to question 2. Question 2, solve by completing the square. So in this instance, we're told the method we must use. So I'm going to begin just by writing out my starting equation. X squared plus 6x plus 5 equals 0. Now, a lot of you have perhaps seen from my previous videos that when I solve equations, rearrange formulae, I like to draw a mini margin. Here we go. How do I complete the square? Well, first of all, we half our coefficient of b. In this case, b is 6, half of 6 is 3. Still squared. I must have my plus 5. And on the end, it's a non-negotiable. It is always subtract whatever your half b value was, in this case 3, squared. And still equals 0. Let me tidy things up. That will give me x plus 3, all squared, subtract 4, equals 0. I've got to solve. So now I add 4. So I will get x plus 3 squared equals 4. If I take the square root, I'll get x plus 3 equals, remember, you are looking for the highest grades possible in GCSE Maths. The square root of 4 is not simply 2. The square root of 4 is plus or minus 2. To make x a subject, I now need to subtract 3. So I get x equals plus or minus 2, subtract 3. Well, I can take that further. Let's work out x1. I have 2 subtract 3, which equals minus 1. And to work out x2, I could have minus 2 subtract 3, which equals minus 5. And there are our solutions. Question 3. Solve using the quadratic formula x squared plus 3x minus 7 equals 0. Give answers to 3 decimal places. Well, the first thing I'm going to do is correctly identify a, which equals 1, b, which equals 3, and c, which equals negative 7. I am now going to substitute into the quadratic formula, which of course is minus b plus or minus the square root of b squared minus 4ac all over 2a. Now if I just draw in my lines here, just for that absolute clarity, I'm going to use a ruler as well to keep things neat. So substituting in, I'll have minus 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 7 all over 2 times 1. And again, just drawing in like so. That will give me minus 3 plus or minus square root of 9 minus 28 all over 2. Like so. Minus 3 plus or minus the square root of 37 all over 2. I'm now going to work out x1. To work out x1, I will do minus 3 plus the square root of 37 all over 2. And to work out x2, I will do minus 3 minus the square root of 37 all over 2. Let me draw my lines in for that absolute clarity. Like so. Take a scientific calculator. Like so. So negative 3 plus the square root of 37 divided by 2. Change the format of my answer to 3 decimal places. I'm getting 1.541. I now need to work out x2. Minus 3, subtract the square root of 37. Divide by 2, change the format of my answer to a decimal, and to 3 decimal places, I'm getting minus 4.541, like so. Let's look at question 4. The equation x squared minus kx plus 24 equals 0 has 2 integer solutions. Find all possible values of k. So just remember, when we factorise, and let's just say we put this in the form x plus p, x plus q, p plus q must equal b, and PQ must equal C. So in this case, PQ must equal 24 and P plus Q equals negative K. So what we need is, we need all the factors of 24 in their pairs, but because K is negative, we need the negative of those pairs of factors. I'll try and show you. It's easier to show you than it is explain. So here we go. Negative 24 times negative 1 equals 24. Negative 12 times negative 2 equals 24. Negative 8 times negative 3 equals 24. Negative 6 times negative 4 equals 24. I don't believe I've missed any pairs of factors. But we now need to work out this value of k. Well, negative 24 subtract 1 equals negative 25. Negative 12 subtract 2 equals negative 14. Negative 8 subtract 3 equals negative 11. Negative 4, or negative 6 rather, subtract 4 equals negative 10. Therefore, k equals negative 25 or negative 14 or negative 11 or negative 10. As always, if we've touched upon any topics in this video that you think you might need further support with, please check out our other videos. But for now, the very best of luck in your quest to achieve one of the highest grades possible in GCSE Maths. And as always, thank you for watching.